Welcome, everybody, to another edition of Coffee and Open Source, a place to meet some new friends, have some great conversations, and maybe learn something along the way. I'm your host, Isaac Levin. And if you're enjoying the conversations here, be sure to like, subscribe, follow wherever you're watching or listening. And if you know anybody or yourself would like to be on the show and chat, just reach out to me on Twitter. My handle there is Isaac R. Levin, or you can reach out to me on Mastodon. My handle there is Isaac R. Levin at fossendon.org. All right, so with that out of the way, I'm looking forward to this conversation. We were chatting about all sorts of different topics before we got started, and I'm looking forward to continuing the conversation. So my guest today is Jim Bennett. So Jim, tell me when technology first introduced itself to you.
Yeah, so I grew up in kind of a privileged middle-class household. And right back in, I think it was like 1983, my parents bought our first computer. So ZX Spectrum. So didn't make it to this side of the pond. This was back in the UK. And it was like a small 48 kilobytes of RAM, rubber keys, metal case. You had to plug in a cassette deck. If you remember cassettes, plug in a cassette deck to load and save games or whatever from this thing. Anyone in the US, I guess, if you had a Commodore 64, it's kind of that era of computing. And the cool thing about the Spectrum is, obviously, you could put a tape in and load a game, or when you turned it on, it would launch into a BASIC interpreter. So you actually start writing code in BASIC and then save that to a tape. It actually came with this big, thick manual. It's an orange manual. It's ring bound. I can still remember what it looks like today. And in there, it taught you how to write BASIC programs.
Yeah.
So I would start, literally at the age of like 6, 7, I started typing out BASIC programs, 10 print hello, 20 go to 10. That kind of thing, and just kind of building very simple, basic games. Like I was hooked. Absolutely loved this. Obviously, young kid, no attention span. So I'd start typing a game out, get bored, and got to give a shout out to my mum. My mum, non-technical, but she always would jump in and she would start typing out some of the games. I'd type out the first part of tic-tac-toe. She would type some out. I'd type some out. She'd type some out. And in the end, we'll get a game and we kind of play that together. So she kind of really helped me kind of get going with writing games. And of course, back then we had no internet. So if you wanted to learn how to do things, you had the big orange book.
Yeah.
The local library had books as well. So once a week, we go to the library and it'd be in the computing section trying to see if they had a book. And if they didn't have a book, I could order it and wait another week or two for this book. Very slow process of learning how to code. But the downside back then as well is these computer things were new. So my parents were always a little bit worried about how much time I was spending on the computer. So in the end, they kind of wanted to cut down that time, not knowing whether it's a good thing for your health or a bad thing for your health. Is it good for a kid to be there all day writing games? Who knows? Yeah. So they kind of cut the time down, which meant I wasn't able to write the games I wanted to write. Halfway through a listing, your hour's up. I was like, well, it's going to take me 5 minutes to save it. Sorry, your hour's up. So you lose what you've done. So kind of lost interest a bit there. Obviously, my parents were trying to do the best thing they could for me as a kid. So totally, really grateful for the fact they even thought about this. So it was nice they really considered the health of a child. Would have been nice to have more time with the computer, but it's nice to have parents who can. And then, at school, computing wasn't really a thing. I did a GCSE, like exams to do at 16 in IT, where it was Excel and Word. And so no real programming. So I kind of just lost that whole programming thing. Ended up going down a science route, started liking chemistry and thought, I'll do a degree in chemistry. I like it. Seems fun. And one of the universities near me offered a course in what was called computer-aided chemistry. So you did some chemistry, but then you did some computing as well. So you actually could do things like learn how to program. And then a lot of chemistry, you have big bits of funky kit. You learn how to program that kit. So I did this degree, and the chemistry was, but the computing side, that was fun. First day of our computing thing is you need to build a molecular weight calculator. So given a chemical formula, what is the molecular weight of this? Okay, fair enough. And here's Visual Basic. And you can drag buttons. And so they showed us how to do things like that. So on there, you're dragging buttons on to build a periodic table. And then as you click them, it starts adding up the molecular weight. And I was like, this is amazing. This is so cool. I've just drag, type a few words, and I've got this program that works. And it was just eye-opening. And that was it. It's like, that was it. I am hooked. I've got to do this full time. And so from there, it's like, my degree had like a year internship. It's like, right, I want a job programming. So I ended up working for what was SmithKline Beecham back then, now part of GlaxoSmithKline, pharmaceutical company, on a software team, building software. Graduated, so I'm going to go into software. Ended up working for a chemical information systems company. It's kind of leveraging the chemistry to use the software. But really, it was that first programming lesson where we started in VB that was like, I'm hooked. This is back to what I enjoyed doing as a kid, writing software. And yeah, that was it. Chemistry, don't care. That was where my career started.
Yeah, it's absolutely wild how like something as simple as you see the result that you're building. Like I think that's one of the things that's really really interesting about technology specifically is that you put in this work and like you have no results. Like it's not a very result oriented world and like until you get to the very very end and then you can see all the things put together. It's not like you're building something physically where you can see like okay, after step 1 it looks like this and then step 2 and whatever, right? It's more like I have this black box I just throw stuff in and then at some particular point in time in the future something shows me that I'm doing the right thing or not, right? And I think that I talk to people a lot and when they're getting started in tech and it's like that is what you live for. You live for like all this mystery, all of this pain, all of these things to put up with what comes out of the box when it's successful, right? So like so going through your like the beginning of your career, like what are some of the things that you came across which you're like, oh, like that's not something that I expect. Like I imagine you have like some great like especially in the like I don't know anything about molecular chemistry or molecular biology or any of that sort of stuff, right? So like how much of it was adapting the science to the tech or how much of it was just like building tech based on use cases like 99.99% of developers out there do?
So a lot of it was adapting the tech to the chemistry.
Yeah.
So, thinking about what I did at uni, molecular weight calculator. I mean, that's fairly easy. You have a whole of buttons and each one's got a number. When you click on it, it's like this one adds a 1 to it, this one adds a 2 to it. That's easy. But I moved from there to a company that built this kind of chemical information systems. So the idea was you could take like a database and you could add a chemical structure column to it with an index on there. So you could actually search a database for chemical structure. This thing was quick, million structures, 0.1 of a second, you could do a search. And this was back in 1999. So this was really, really quick stuff. And so a lot of that is, I understood the chemistry. I have this chemical structure, but how do I take the technology and use that to build a representation of the chemistry? Yeah. So I don't know if you ever did any organic chemistry. We have all the hexagons and lines.
I stopped in organic chemistry because I realized that I was just not built for it. Let's just say that.
But yeah, I get if I draw like a structure, like the hexagon with all the lines coming off it, you understand what that was. And so that's a chemical structure. So you're approaching it like I understand the chemistry of this, but I need to understand this from a computing term. And so how do I model this? Well, actually, there's this thing called this idea of graphs. So have this idea of graph theory of nodes and edges. And actually that maps to a chemical structure. Sure. An atom is a node and a bond is an edge. And it's essentially what's called a colored graph because each atom has a color, which is the atom type or other chemical things about it, whether it's charged, whether it's an isotope, whether it's a radical, things like that. And so you can kind of take this theory of a colored graph and apply that to chemical structure. So you're trying to research this theory. I can use a graph to build my structure. And then when I want to look for, is this fragment here a part of this structure? Well, actually, again, under graph theory, there is graph searches where you can actually do a map between the two. And you build, it's like an Ullman backtracking graph walk. So you kind of walk through each one at a time. Do they match? If they don't, you backtrack and start walking again. And kind of all this sort of computer science theory suddenly applies to the world of chemistry because you're looking at the chemical structures through the eyes of a computer scientist. How do I represent this in the digital world? And it kind of just opens up this whole lot of power of what you can do. And that was really eye-opening, that there are ways we can model the real world through a computer. And that's kind of the biggest wow moments of, especially at the start of my career. It's I can model all this, and if I can model this chemical structure, what else can I model? What other things can be done? And then you start to realize that yes, there is a way of doing everything. And I mean, even that recently, I was doing a lot of Internet of Things work with the idea of digital twins, which is a digital representation of the physical world. You have machines gathering data, you have a digital representation. It's essentially the same thing, we are taking reality and creating digital versions so that we can do manipulations with it. So yeah, that was one of the biggest things that opened up my eyes. And then just how you can think about translating that into other ways. So the way the chemical structure database search worked is you need an index. You want to search a database, indexes are quick. So how do you index a chemical structure? Well, you do it by you look at fragments in the structure. You can say, right, I've got carbon, 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 chlorine. Here's a fragment. And then I use that to essentially set some binary data. So you have a big long binary string, and you say, right, if I have this fragment, I feed a number generated by the atomic weights of these different, or the atomic numbers of the different elements into a random number generator, get the first four numbers out of that, obviously are seeded ones, first four numbers out of that, and we mark that and we set those to be ones in a binary string. And then you do that for all the fragments in your structure, and you end up with a string of ones and zeros. And so any two chemical structures, those two binary strings will be identical if the structures are identical. So you can quickly say, are these two the same? If they are, they're identical match. And so really what started off as a chemical structure comparison becomes a quick string comparison to see what's the same. And then if it comes out the same, you then do the actual detailed structure comparison just to make sure it is actually the same. So suddenly you're doing really quick because the index is designed, well, the database is designed for strings, and you've got the whole of strings. And then you whack on, if you want to do a subgraph search, is this fragment part of this whole bigger thing? Well, because we're setting with all the ones and zeros, we can do an and. So if the main structure is and it with a substructure, if it's the same as the substructure, we know that substructure is part of that bigger structure. So suddenly you're using a binary representation of the things that make up a chemical structure to see whether this fragment is part of this bigger structure. And of course, that's just a simple binary and comparison. So you can run those across a million records really, really quickly. And it's just amazing that somebody came up with this idea once, and you can apply it, and you can put it in a real world situation where you have a chemist who doesn't know anything about computers, just knows that I need to make this structure. Do we have it in our systems anywhere? They do a search for it. It says, yes, they've got it. They don't know the magic that's happened under the hood, but that magic has allowed them to get that search really quickly. And that magic is just tech. It's nothing chemistry. It's just tech.
So this is something wild, right? So you're talking about things, to be frank, like I know very, very little about. But you start talking about them in terms of technological capabilities, and I'm starting to understand how things work. And it's so funny if we go to the traditional route, we go to university and we get our first job, we don't know anything about like the business domain, right? Like my first job was in insurance, was in the financial industry, right? I know nothing about insurance, but after 2 months, 3 months, I started learning the principles of how insurance companies work because I have to build the technology that works for that particular industry. And it's quite fascinating. I never really thought about it until when you're kind of describing this. I'm like, well, that's a very interesting way to learn how businesses work, is by implementing the technology needed to run that business. So, and you can kind of, as long as you know technology, like this is a gross overstatement, but as long as you know technology, you can kind of get a job in any industry, right? Like, obviously you have a tech job, but you're implementing technology to solve problems for certain industries, right? Because all you're doing when you're talking about edges and nodes and binary lookups and all these things, you're just talking about technological terms, right? Most people will learn like in a computer science curriculum or information systems curriculum, right? So I imagine that you realize that at some point, and you were like, okay, well, maybe molecular biology isn't for me. Maybe this, pharmaceutical company isn't for me. So what was kind of the next industry that you moved into? And I imagine it was radically different than that, right?
It was somewhat different.
Yeah.
So I mean, this was back in kind of the early 2000s. I've been working with this company for like 5 years, doing C++ because we're doing lots of stuff there.
Everyone does C++, right? Like
you gotta start with C++.
Yeah. You have to at least do one like really bad C++ program in your career, right?
Yes. Yeah, I've done a lot more than one. But yeah, as you say, I was learning how that you can model the technology to the domain. So really, it doesn't matter what domain you're doing, as long as you can learn enough to apply the technology to it, you can go to other places. And so this was early 2000s. I was kind of early 20s. My next thought was, okay, this is fun. I'm earning a reasonable amount. I could do with a big stack of cash now, please.
Yeah.
As you do. And the one place to go if you want a big stack of cash is the banking world. So I used to live just outside of London, big financial capital, and I wanted a big stack of cash. So, you see these jobs advertised where, we want a C++ programmer with 2 or 3 years experience and the pay is up to £100,000 a year. It's like,
Yeah,
I would
yeah,
my salary,
yeah.
more double my salary. Thank you very
Yeah.
much. So I moved to the city.
To
And
be
I
fair,
started.
too, and I don't know, and sorry to interrupt you, but I don't know when this was, but just for reference, £100,000 is a lot of money, kind of today, right? For like an average person in technology in the United States, like a pound is, I don't know what it is, like 1.5 or something like, right, to the US dollar right now,
A bit
or
less
something
than
like
that, about 1.2, I think,
Okay,
1.3.
well, it's closer to even. But like $100,000 a year is good money for somebody 2 or 3 years out of university, right? And that was a few years ago, I'd imagine, right? So we're talking about really good money.
Oh yeah, really good money. I mean, yeah, there were costs associated with it. I didn't want to,
Sure,
if I lived
sure.
in London, very expensive place to live. I
Yep,
lived outside of London, so the train fare was expensive.
yep.
When 5-10% of your take-home pay is going just on your train fare, that kind of adds up. And
Yeah.
but yeah, it was great. I didn't manage to land the £100,000 a year job, but I was still earning substantial quantity. It didn't take
Sure,
me
sure.
long to get into that £100,000 a year bracket. So I was working on a thing called convertible bonds. So it's kind of it's just basically working for a trading desk. They're
Yep.
doing stuff. You understand enough of the business to build the things
Yeah.
that you need to build.
Oh, sure.
So
Yeah.
it's applying that. Here is a domain. How do I take technology and apply the stuff to technology? And it's actually, honestly, it's a lot easier than the chemical structures.
Well,
It's a
it's
lot
funny
easier.
because you go from working with bonds to working with bonds.
Yeah.
Sorry. I had to.
Bizarrely enough, that
Yeah.
never actually crossed my mind until now. That yes, I
There you
did that. I
go.
went from
There you
bonds to
go.
bonds.
Yeah,
There we go.
but so one thing that's always really fascinated me about the financial industry, especially like the banking world, is like this, and I don't know if it's as much in what the company that you're working for was doing or the things that you're building, but like performance is like of the utmost importance, especially like if people are at the trading desk and like, oh, I need to be able to react to when the stock price changes or whatever, right? Like you talk to people that are building those sort of tools or those sort of platforms, and like they're worried about like the millisecond, nanosecond, like fractions of milliseconds, like those sort of things from a performance standpoint mean a lot. Was that something that you had to focus on? Because I don't know so it's a different kind of performance change. Like when you have large amounts of data, like with the organic chemistry and molecular biology stuff, right? Like you're talking about tons and tons of data, so you need to be performant to process that much data. Where else on this side, you need to be fast to react as fast as possible with as much compute. Like, did you have to kind of adapt the way you thought about solving problems when you went from dealing with tons of data and you need to be performant to working kind of in a very high performant, high transaction based, domain?
Yes and no, and that sounds like
Sure.
a bit of a cop out answer.
No, it's fine.
So
It was also a long time ago, so you could just kind of punt it and say yes, and then we can move on, right? Like,
no, I mean, so when I first started, I wasn't doing the high performance trading, and that came towards
yeah,
the end of my career in banking. So I did banking for quite a few years, and towards the
sure,
end, I was building an FX trading platform.
yeah,
Sorry, not FX. So I did FX for a while, then I moved on to an equity trading platform. Sorry, an equity trading platform, and that needed to be performant. And so I was building the front end, and of course, you need to see price updates instantly.
yep,
So you need to build that really fast system. It's got to be fast. It's got to be performant, so that not just updates quickly, but as a user, I can go bang, 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 and do something. So not quite nanosecond. That was more the back end algorithmic folks. This was more front end, so it need to have a really fast UI.
yep,
But when I was trying to think about building systems for you're handling lots of chemical data, you want it to be fast, and to make it fast, you need to obviously tune it, and to tune it, you have to profile.
mm-hmm.
There's no point in thinking, I think this is slow, I'm going to fix this. You want to run a profile over it. So I learned a lot about profiling, profile guided optimization, how to look for those spikes. Yeah, how to actually find the things where can you have the most impact. This thing here takes 1 millisecond, this thing here takes a minute. Well, the thing that takes a millisecond is called a billion times, whatever. So that's
Sure.
where we can get better bang for a buck. This 1 minute thing is called once. So I kind of learned a lot about profiling, and that was a really good set of skills that I had, and that carried through the whole banking world. So suddenly, when I'm there rolling out a brand new trading platform, I need it to be fast. So what do? I connect my profiler, I connect up to production, I start getting things going, and I'm there looking for those hotspots. So it's the same techniques I learned for optimizing with vast quantities of data, still applied when you're optimizing for a fast UI. It's learning how to see the places that are slow, working out where to divert your energies, and then how to optimize those, or even just delete them. What code can I take away? Because every line of code eats a certain amount of CPU cycles. So what code can I delete? What's not necessary? And sometimes that is going back to the users and saying, hey, you wanted this feature here to flash this price 3 times. If I flash it 3 times, it will actually slow the system down. Whereas if I flash it once, it's a smidgen faster. So here's the comparison between the two. Which one do you want? Oh, I want it once, please, because speed is more important. And so you end up realizing that performance is a feature. And a lot of times people don't think this. They think, oh, whatever, it's fine. But actually, performance is a feature. It's the old, if a web page doesn't load in so many seconds, people will leave. So it's important that you have those features there that include the speed that it runs at. So that was a big learning.
It kind of doubles down on our conversation earlier about like adapting the principles of technology to different domains, right? And like something about performance, right? Like I've been an quote unquote an observability nerd for a long time, right? And it's funny how it took so long, like 60 years of computing, right? Before like let's care a lot about the observability about our technology, right? Like let's make sure that we're I'm guessing it's tools based. Like the tools have been more prominent, so like now people care about it. But I remember being like a line of business developer, and it's like, oh, like the website loads, like takes 2 seconds to load. Okay, the users are fine with that, right? Whereas like you don't even really think about that in the grand scheme of things. Like like it gets bolted on at the end. Like ship feature, ship feature, ship feature, ship feature. Okay, what are the last 2 things? Okay, performance and security, right? Now you look at the industry today and like what are like the 2 most important topics when we talk about building new systems? Observability and security, which is just absolutely wild to me how we've gone from not really caring about it to like, oh, like these things are like first party problems that need to be solved when we're building systems.
I think part of that is because we've got really good at solving the other problems.
Sure.
In terms of features, I need a system that does X, Y, and Z. Well, I can build that. So or you can find it
because somebody's already built it, right?
Yeah, that part of the problem is kind of easier to solve. So now we've got more capacity to think about things like security and performance. Plus, we have more competition now. So sometimes it is just down to who's faster. Yeah. So if your website doesn't load, I'm going to go to the next one. So again, that becomes important. And then just the whole security thing. There's now more people hacking. So you've got to think about security space a whole lot more now, because the chances of being hacked back in the early days of the internet so much lower than now. And then just the fact we are more connected now. I mean, I did an internship once for a military company, and they had a whole network that wasn't even connected to the internet.
Yeah.
Any application you built there, they didn't care about security because it wasn't connected to the internet. But now everything is connected. Even your fridge is connected. So when was the last time you thought you have to put security in your fridge? But now you have to.
Yeah, that transitions really well into this next area of topic, right? So like, so you mentioned a little bit that you're building like front ends and UIs, right? Like, and if anybody who knows Jim for a good amount of time was like you worked in Xamarin, you worked in building mobile apps or apps that don't run on traditional devices, right? And like you mentioned, like running on your refrigerator, like running apps on your refrigerator. Like Jim is also really big in the IoT space, and I'd love to talk about that a little bit. Like when did like the non-traditional computing platforms become interesting for you?
So this would have been probably 8 years ago, 9 years ago. I'd done the banking thing for a while, and it was a very toxic culture.
Sure. Yeah, that's fair.
Very, very toxic. It was racist, sexist, homophobic, transphobic, you name it. It was a
Yeah.
nasty, nasty culture. And unfortunately, it's easy to get sucked in. And I found I was starting to get sucked into some of the cultural sides of things, including just the whole take culture.
Yeah, yeah.
You know, when you've got I used to have a desk on a trading floor in Hong Kong, and the trader sitting next to me was really annoyed one year because his bonus wasn't big enough for him to get the
Yeah.
McLaren that he wanted.
Yeah.
You know, they're in Hong Kong, the speed limit's 30 miles an hour. You don't need a McLaren. You know, oh no, you can't get the McLaren you want. You have to get the other McLaren to park next to a Lamborghini. Seriously, you know, get off your case. But things you end up being pulled into that lifestyle. You earn a lot of money, but you're also there buying champagne on a night out and things like that.
Yeah.
And I realized it was quite toxic. I wanted to get out. It's like, I want to get out of this, and I want to actually start giving rather than taking. So how can I do something I want to give? And I want to learn something new. Yeah, I've been doing C#. I moved from C++ to C#, doing C#, doing front ends, WPF for ages. How do I move into something different? And I've been playing with the old iPhone for a while. Yeah, everyone loves an iPhone.
Yep.
We got an iPhone, tried some Objective-C programming, which was horrendous, but I tried that because,
Sure.
you know, this iPhone thing was a bit of fun. And then I was watching, it was a Microsoft build, and they were showing off this Xamarin thing. It just got, I think it may not be Microsoft, it might be another Microsoft event. I can't remember. It's too long ago. But they're showing off the Xamarin things that you can basically build .NET and run it on your phone. It's like, well, I've been a C# developer for years. This sounds like fun. So
Sure.
fired it up, built a thing. Experience was terrible as it was back at the start, but it was great. I could build an app for my phone in C#, and I had it in my hand. And where I've been doing a lot of UI work, I started to think about this kind of tangibility of things. How do you interact with a computer, that kind of human computer interaction? And with a phone, it's a more personal human computer interaction. It's not just on a screen, it's portability.
Yep.
You know, the computer on your desk, you can't take it with you, but
Yeah,
your phone.
well, let's be real, right? Like, what do they say? Like, the average person touches their phone 6,000 times a day, or some absurd number. I saw that somewhere, and I was like, I'm not going to disagree because I touch my phone a lot, but 6,000, like, you just do the math. The average person's awake 16 to 18 hours a day. That's, literally 400 to 500 like times an hour. Like, that's crazy. I don't know if I did the math right there, but like it's
a lot. I feel that's a bit high.
Yeah.
But the thing is, it's not just the phone as well. I mean, I used to have the original Microsoft Surfaces.
Yeah.
Not the original table one, but one of the small ones.
Like the little tablets.
Pro thing. Yeah. Yeah. And just the fact that I was showing this off at the company I was at. So if you were to work on one of these, you pick it up and go to a client meeting with you. You take it with you. Yep. You know, most of them had big, powerful machines on their desk because it's a trading floor. But if you're in a meeting with a client, how do you get that data up? What do you pick this device up and take it with you? So there's a whole lot of stuff to think about that. So I want to try this Xamarin thing out and tried it. It's like, I'm hooked. I am hooked. This is brilliant. I can build a mobile app so quickly.
Yeah.
And as I said, at the time I was going from this toxic environment of the bank, take type environment. I want to be give. So I'm going to learn this thing. I actually took some time out, moved to Thailand with my wife and child, but when they were very young, spent like 6 months in a co-working space in Thailand, no distractions, learning Xamarin. So as I learn this, I want to give back to people. So I want to be one of those community people. Yeah, I'm going to ask a question on a forum, but in return for an answer, I'm going to try and answer someone else's question.
Sure.
I'm going to try to look up answers. I'm going to try and work out answers for people. I'm going to write a blog post. I'm going to, record a video. I'm going to go to a conference, and I kind of just got into that community. Yep. And so because I was part of a very welcoming community with the technology that I was really loving it, because my app, I put it on my phone, I take my phone with me, I show it to people. I can have an app on my phone interact with an app on someone else's phone, and we kind of have this connectivity. And it was just amazing. It was just absolutely eye-opening that we could do this. And so that was it. Just completely hooked. And it's like, as I'm doing this, I want to do more and more and more. And I just get complete Xamarin nerd out of that.
Yeah, it's funny how, and I have a similar like path to like the community stuff that I enjoy doing, right? Like you kind of get like that first taste, and I think there's kind of like there's folks that they want that sense of community, like they want to establish connection with people in a particular way. Like everybody's trying to find our tribe, right? To like use some anthropological thoughts, right? So like, this technology thing, like there's a community all around it. Like everybody has heard the story. Like my first foray is I was at a Microsoft build, and I ran into a friend who was a Microsoft MVP at the time, and he was talking about like writing docs, and I was like, oh, like anybody can do that? I didn't know that. And I wasn't like I don't love writing, but I like the idea of like I don't need to work for a huge company and know the ins and outs of every single thing technology wise, but I can still contribute to the community in a particular way. And I wrote a
Hmm.
doc. Like at one point in time, it was like the most viewed doc on the docs.microsoft.com platform. Like it was like how to migrate
Wow.
from like .NET Framework or ASP.NET to ASP.NET Core. That was like the first doc I wrote. And let's be clear, like none of that doc is still alive. It's been rewritten probably 1,000 times in however long ago it was. But like I got that taste, and then immediately I was like, I got to do this. So I started like finding like speaking at community events and doing the thing that you're doing, like started blogging and started like messing around and like just trying to like meet people, and like now I'm here and like I'm doing this thing and I enjoy it, right? Like,
Hmm.
is it like, and it's hard now because I think about like, oh, could I just drop out of the community completely and like go work and be a back end like line of business developer at a bank or whatever, and like, and I was talking with somebody is like, I don't think I could. I would rather get paid less than work a job where I like the community part, like community stuff isn't directly part of the job in some facet, right? Or at least doesn't give me the opportunity to do community stuff. Do you feel the same way? Like I could kind of think I know this answer, and you can kind of provide a little bit more context. But when did you realize like the community is like it? Like the technologies can change, the technologies can ebb and flow, but the community around technology is the thing that I enjoy the most about it.
I think it was discovering the Xamarin community, discovering just how helpful people were. I mean, I've been a part of non-tech communities beforehand. I used to drive a British sports car. I was part of a big car community for a while, and just getting together with people. We used to have black tie events every year and things like that. Just getting together with people that were part of your tribe was really nice. Having that shared interest. You meet people. You already have someone to talk about. I mean, this was back in the sports car community. You meet someone new. What car do you have?
Yeah,
And then you just geek out on cars for a while. You know the person's name, but you spent an hour talking about the comparisons between
sure,
different
sure.
versions of TVRs. You do that kind of stuff. But yes, same as in the tech industry. It's just having that tribe of people who want to support you and help you, but for the sheer joy of supporting and helping someone because you have that common interest in what you're doing. It's not transactional. It's
Mm-hmm.
not what can I take from you. It's we're going to geek out on this thing, and I might be able to share some knowledge with you.
Yep.
And this is great. I mean, one of the real hooker moments was the first ever meetup I spoke at. So I went to a couple of meetups, got chatting to some people. Chatting to a guy called Dave Evans from the UK. Used to run one of the meetups there, and he was saying, "Oh, you should come to my meetup. You should come and talk on my meetup. Go on, you should try this." I was like, maybe I don't know.
Yeah,
And
yeah,
then he
yeah.
convinced me to do it. And I was playing with iBeacons at the time. So little Bluetooth beacons. I was playing with some of those. So I gave a session on iBeacons, how you can write an iOS app in Xamarin to talk to iBeacons. So I got some of these iBeacons and went along, and there were 6 people at this meetup,
Mm,
and it was the best thing ever. It was small
yeah,
enough that we could get hands on together. Everyone tried to build their first iBeacon app because you can do it in 10 lines of
sure,
code.
sure.
And it was just amazing seeing the joy you could bring to people by sharing something and
Yep.
then just geeking out with them. And it didn't feel like they owed me anything for teaching, and didn't feel like I owed them anything for coming and learning. It was, we're just peers.
Mm-hmm.
We want to support each other. And so I'm going to share this with you. And then next we're going to come along and you're going to share something with me. And it was just that deep love for the technology. And it didn't matter who you were as a person. There was no differences, boundaries. There was the people there may not necessarily been the people I would have been friends with if it
Yep.
wasn't for the technology, because we were such different people.
Mm-hmm.
We didn't have any other commonality apart from the tech, but yet you go to the pub afterwards and you're there geeking out for 2 or 3 hours.
Yeah.
So having that core love together just brings you together as people, and that was it. It was like, yeah, I found my people. I want to do more of this. So I think, yeah, like every now and again you think, maybe I should do an engineering job because it seems a
Yeah.
lot less stressful.
Sure,
But if I
sure.
did, I'd still want to be part of the community. I'd still want to
Yeah.
get involved. I still want to do this. I mean, I could never work for Apple, for example, just because of how strict they are on secrecy. It's like,
Yeah, yeah.
no, I want to go and geek out the tech that I'm playing with. I
Yeah.
couldn't work for you for that reason.
Yeah, it's funny that you mentioned like the stress level, right? Like I don't find the community stuff super stressful for some reason. I don't know why. But like you said, like an engineering role, like I told myself, I don't know, 6 years ago or something, like I'm never gonna ship software again. Like, cause I did that, like I was a consultant, I did all sorts, like I like in again that's shipping software in a different way that's very stressful. But I very
Mm.
much was like, the putting the pressure on me to like hit some deadline, that I have all these dependencies on other people. And sure, like you have that when you're creating content and stuff like that. However, like I guess maybe it's I enjoy that stress a bit more than the stress of like having to bang out a bunch of code at a particular time, right? Like, but I think what's really interesting, and this is kind of what I want to delve a little bit into, kind of like the developer advocacy work that you've been doing. Is like, we all find out, like, I think what we're good at or what we think we're good at enough to enjoy doing it, right?
Mm.
So like, when were some of the things, like, obviously you have a passion or an interest in, like, the IoT space, like, playing around with that, like you decided, like, oh, okay, like there's not a lot of people talking about this stuff, like, so I'm just going to talk about it. So like, how do you go through, is it just playing with the technology for you to realize, like, oh, I'm enjoying this, I want to talk about it more and more and more with the community?
So I think you need something that sparks enthusiasm. You just see that thing, go, oh, this looks like fun. Just
Yep.
enough to get you going, enough to motivate you to play with it. And then
Mm-hmm.
when you play with it, you need that, yeah, I like this moment. I've
Yeah.
played with some technologies and like, no, don't like this. It's like,
Yeah.
yeah, but I first tried to learn web stuff, play with it. It's like, nah, don't like this, don't like this. But with the IoT stuff, so I was at Microsoft. We used to get together as a team twice a year. So twice a year, all the team would fly together, and that was obviously back, pre-pandemic times,
Sure.
and we'd do stuff. And I used to work with Suze Hinton. So I don't know if you know Suze.
Yep. I'm
She's absolutely
friend
phenomenal.
of the show, Sue's Hidden. I talked to her. Feels like years ago now, but we talked about all sorts of fun things. Yeah. Like, yes. Continue. Sorry.
So no, she is awesome. And yeah, she was obviously an IoT person at Microsoft at the time, the developer advocacy focusing on IoT. And so during our team get together, she did a session on IoT. She had these little boards, MX chip boards, and she gave a demo of these things and said, right, who wants a board? I was like, well, this is fun. And it kind of felt like a natural progression because, talking about the phone, put apps on the phone. I take it with me. There's sensors on the phone. Like the phone is like an Internet of Things device, but she's got this little piece of hardware. So I want to play with one of these. So I got one from her and I built something and it was like, this is fun. I love it. Yeah, it's one of the bits of technology that when I actually put some time into learning, I was like, I really enjoy this. And because it's a tangible physical thing, I can wire bits up to it, I can do things. It became really exciting. Kind of about that time, my role at Microsoft changed a little bit. I moved from purely Xamarin to kind of focus on an educational space, which meant I could spread my wings a bit in terms of technology if I wanted to.
Yeah.
It's like, no, what? Yeah, students love Raspberry Pis and IoT devices and other gadgets and gizmos. So I want to play with this more. And I managed to kind of dive into that space. And it's just having that ability to build something that you can interact with that's not tied to your desk.
Yeah.
The
Yeah.
natural progression from there, like we're saying with the tablet, you can take it from your desk, take it to a meeting. It's now a device that's connected to your house, that ubiquitous computing. It's a device you can carry with you. It's a wearable. It's just that fascination with the movement of computing. It went from the big mainframes like the 60s to the desktop to your pocket
Yep.
to everywhere.
I think it's like what I really enjoy. I geek out a little bit on this sort of stuff too. Like, I'm actually, I hope my kids aren't watching this. I'm building a present for them, like using a Raspberry Pi. I'm building like one of those like retro Pi arcades.
Oh, nice.
Yeah, so
Nice.
that hopefully they didn't hear that and like, oh my gosh, I know what I'm getting for Christmas. Anyway, I just like the accessibility of it. Like, I mean, maybe not as much now because Raspberry Pis, like, some of them sometimes hard to get a hold of them. But like micro boards, like there are tons of companies out there doing it now. Like, like whether it's the the Meta with the Wilderness Lab folks, or Raspberry Pi, or there's all sorts of different companies that are making these boards. They're really, and they're it's a lot of compute for a small amount of money when you think about it, right? Like,
Oh, yeah.
Raspberry Pi 4, the last one that I bought, I think it was like $40, right? Like, try buying a a fairly performant PC at that price, like good luck. Like you can find like some old like Dell Optiplex like used server things, but like who wants to do that? And then they're like this big versus this big. Um,
Mhm.
I just love like, and you can just do like whatever with them, like, and it teaches you like, especially like if you're someone like me who has been building things with on Windows for so long, like your primary operating system has always been Windows, you have to learn Linux. Or at least learn enough to like at least learn Bash, like the Bash shell, and like learn how operating system works a little bit in Linux. Like it's great. Like, it teaches like via osmosis, like you're learning this new technology stack, like just trying to like get a Python app to work, or like trying to build like some little silly thing.
And if you can go further than that, you get like a microcontroller. There is no operating system, and
Yeah,
so suddenly you have to learn about memory.
yeah,
I have to care about memory because I've only got 16 kilobytes of it,
yeah,
and it kind of takes you back to the days of when you did have to care. Now
yeah,
it's like whatever, I don't care about memory size, but it kind of takes you back a bit. I think though you sound about it's accessible. I think one of the downsides to the Internet of Things is how inaccessible it is for developers. It's getting
yeah,
better,
yeah.
but it used to be you had to do C++.
Sure. Yeah,
And and things, the libraries wouldn't work the same way. Even with like Arduino trying to unify it, well, this Arduino thing won't work on this board because the manufacturer hasn't provided the right headers for it. It's got a different name and a different interface, and it's a pain. And like, and the Raspberry Pi obviously helps. You can write Python on there, but it's a more powerful device.
mm-hmm.
So the stuff that Wilderness Labs are doing with the Meadow, bringing .NET to an IoT device, that's really helping with accessibility.
Yeah,
So it's a growing space in that there are companies trying to make it easy.
mm-hmm.
Adafruit with their Circuit Python and their devices for that. You write a bit of Python and you've got a device that can do all these cool things. So there is growth in this space, but it's still not as easy as it is for modern developers.
Sure.
If I'm building something for the web, for it be a backend code to run on my Mac, I've got so many choices, so many powerful tools. I want it to run on a teeny tiny little device, not so easy. And that's why I love companies like Edge Impulse, for example. They do on-device inference for AI models. So you want to train a microcontroller for AI. They've got a whole suite of tools. They generate the code, everything. So literally, you just run a command line tool. It will capture data from your device, build the model on the web, and it spits out the code. You run it on your device, and it's done. And just having that accessibility of making it easy to do things is really, really powerful. And it's coming to IoT. It is coming, but it's not quite there yet.
Yeah, that's like I do agree with the developer experience thing. Like it's gotten so much better, but yeah, it's not in the early days, a few years ago before like it took off. Like I think yeah, you had to do some crazy things, and like we've talked about this a bit earlier before we got on stream. Like developer experience is so important, right? And one of the things that I love to talk about a little bit is like some of the work that you're doing right now at liblab, right? Like to start out, like if maybe folks who are watching or listening, like maybe they don't know who liblab is and what you're doing there, you want to just do a little intro about them and kind of what your role is there.
Yeah, so liblab is, I guess, fundamentally a developer experience company. So we generate SDKs for APIs.
Okay.
So you think about it, you've got a SaaS platform, you've got an internal microservice at a company, whatever, you will have an API. Usually like a REST API, and people have to interact with that. And so when you're calling a REST API, a lot of it is sending text. When you interact with the REST API directly, you've got to hit an endpoint that's defined as a string. You're sending some JSON over there. You're getting back a response that's JSON, and you've got to handle those magic strings, handle
Yep.
all the JSON conversion, handle retries, set authentication headers, and
Yep.
kind of all this thing. And that's not a great experience.
Nope.
So I imagine you're like every other developer. If you were doing this, you'd probably build a layer of abstraction over everything, wouldn't you? You'd write some kind of layer of
Probably.
abstraction.
Yes.
Every developer does this. You build your DTOs that you map your JSON to. You write service code that wraps all the endpoints that you have. Liblab builds that layer of abstraction for you. It literally will improve your developer experience. You point it at an API specification. So this can be like an open API spec, Swagger spec, Postman collection, and just say, give me an SDK in Python or TypeScript or Java or Go or C#, and then it gives you the SDK.
Yeah.
And it handles all the things for you. So if your API needs bearer auth, it handles that for you. You just set an API token and it does all the bearer auth for you in every single call. If you have to deal with things like retries, you can say, I want to retry maximum of say 3 times with a 100-millisecond delay between each time. It'll do all that kind of stuff for you. It's all very configurable as the SDKs that you can create. And then the idea is what we spit out is a very developer friendly, written by, it looks like it was written by you. It looks like it was written by an expert engineer who understands the technology. And then you can just use that in your applications that you're building. So if you're a SaaS company, you could say use it to generate SDK that you just give out to your customers. If you're an enterprise, you can use it to just generate SDKs for all your microservices. So teams don't have to worry about hitting the different APIs. They can just use an SDK. Much, much nicer developer experience.
So like that's awesome. Like, so the idea that, we talked about this briefly before we got started, like, if I'm building any platform, right, the number two, like the 2 things that every developer cares about immediately is like, okay, what does the API look like? Is there an SDK for it? Like, I've literally like looked at tools, like SaaS-based tools, and I'm like, okay, is there an SDK? Is it in my language? No. Okay, not using that one, even if it's the best option, right? So like, making that ease of use accessible is great. So like, obviously, without going too much into like the secret sauce, is like, how does this work? Are you using like open API spec stuff? Is it using code gen? Like, what are some of the things that that make sort of this like quote unquote magic, right, work?
So a lot of it is based off open API specs. So you obviously have to have that specification. Yep. We cannot create an SDK from an API unless we know what the endpoints are. So it starts from that, say Swagger, Open API, or Postman collection. It starts from that. Obviously, the better your spec, the better the SDK we can generate. So if you have things like descriptions in your spec, examples in the spec, we can bring those into the SDK. We've all done the thing where you tap dot and it gives you the choices and you see the inline documentation. That documentation's got to come from somewhere. So we can kind of take that from your spec. So we kind of take all these details, all the stuff from your spec. We then internally kind of build that into our representation of it, and then we use that to spit out a whole load of different files. And so there's a lot of kind of secret sauce in there, but there's no AI involved whatsoever. I know a lot of people are like, oh, you can use AI to do this. It's like, no, hallucinations are terrible. We can't do that.
Sure.
But we do have to be very, very strict about this, because if I generate you an SDK and then you add another endpoint and I generate you a new SDK, that needs to be identical to your old one except for the endpoint. Because if you think about it, if we have a customer who generates an SDK and they distribute that to 10,000 of their customers, if we do anything that breaks that SDK's interface, if we break that contract, their 10,000 customers are going to be annoyed. So we have to be very, very strict when we generate an SDK that we have well-defined rules. No AI involved, because AI would hallucinate and just change things all the time. So that would just be terrible. But we kind of be very strict that we just, when you generate a new SDK, nothing changes except the new things that you've added to your spec. So it's kind of, there's a lot of kind of magic there, but a lot of kind of internal templating that we do. We have experts in Java and C# and Go and TypeScript and Python who have actually been working on these templates to make sure they're right. We've got a load of customization, because obviously what I want in my SDKs and what you want in your SDKs potentially going to be different, because I want mine to, like I wrote it, you want yours to like you wrote it. So just some things around naming, or how we customize various features. For example, if in Python you can pass dictionaries through, that's just how the Python language works. So what happens if a field is missing? I might want my SDK to error, you might not. So it's kind of things like that. And then we also do things like we look at the validation rules specified in your spec. So if your spec says this is an email address, here's the regex, we put that in the SDK as well. So we can validate SDK side rather than going to the API. So a load of cool stuff like that. We even have a whole hooking mechanism so that if you can actually catch the data before it gets sent. So I make an SDK call and you can actually write code to adjust that. If you want to handle specific auth cases, you can kind of write this extra code that gets embedded in your SDK kind of before the request is sent or after response comes back, things like that. And just designed to improve that developer experience.
I mean, that's great. Like, so I'm a developer. I play around with APIs all the time. Like like maybe I want to play around with liblab. Is there a way to do that today?
So we're still in beta.
Okay.
We are kind of slowly coming out of beta at the start of next year. But you can join our beta. It's an open beta, but we're not open the floodgates to everybody
Sure.
at the moment. So liblab.com is where you can go and sign up. And we kind of have, although we're in beta, we do have kind of 3 tiers that we make available for people to sign up for. So the first one is our basic developer tier. Doesn't have any enterprise features, doesn't have any support apart from our Discord server, and that's free. So that's kind
Okay.
of quite nice. So you as a developer, you want to just build an SDK, we want that to be for you for free. We then obviously have the usual, it's a SaaS platform, it's an enterprise tier.
Yep.
You know, how much support do you want? Open your checkbook. You know,
Mhm.
you want us to kowtow to you, you add another 0 on the end. You know,
Sure.
we all know how enterprise support
Yep.
works.
Yep.
But what we do also have as well is we have an open source tier. So if you're an open source project and you want an SDK, we will not only, obviously you can use our developer tier for free, but depending on the size and scope of your open source project, we'll actually give you free support to do that, and so we'll give you access to our enterprise features for free. So obviously, if you're just one person, you've knocked up an API for fun on the side, we're not going to be spending hours
Yeah.
helping you. But if you're a larger project with a big audience, we can help with things like spec reviews, make sure your API spec is up to standard. We can kind of build those SDKs for you and kind of just help you and kind of give you that level of support that you would get if you're a big paying customer. It's kind of our way of giving back to open source.
No, that's awesome. I mean, we were talking about this a little bit before we get started. Like, there's a bunch of different ways that you can kind of contribute to open source, right? You can do with people, you can do with dollars. This approach is interesting, where you're providing services that typically cost money for free, because some folks need these sort of things. Like, if you are building some open source tool and you need, like, there's APIs, and like I'm not a Go developer, but I need a Go SDK because I know Go developers might want to use it. They can take advantage of liblab and be able to, get that experience to those sort of developers that they would not be able to, right? That's absolutely awesome, and it's an interesting way to get open source folks to use liblab too, right? Because let's be real, like, you folks are doing it because you see an opportunity to grow awareness of the platform and also do better at the same time, which I think is awesome.
Yeah, it gives us kind of feedback on the product from people who are using it.
That are typically more passionate than the average person as well, right? Like, everybody knows the open source developer, like, they'll let you know if they do not like it. They'll let you know if they love it. Yeah, so that's great.
Yeah, it means we can tap into a huge audience. I mean, it's like when you're a maintainer, if someone hates you, they will be mean to you on, as like, we don't. But so if we generate SDK for someone and there's someone who's mean about it on the internet, then that's good learning for us, I guess. But
maybe the way that your folks are building the API, like, I imagine that, you folks, like, you're kind of trying to build the airplane while you're flying, right? Like, there are some things that in some particular domains it might not work as well, like getting feedback from the community, especially like if I'm an open source developer and I'm entrusting you with building something that I'm eventually probably going to have to either maintain or at least be the first line of support on. Like, I want to make sure that it works for me directly, right? So that's like great ability to get like first party like feedback, which is awesome.
Yeah. Product feedback's kind of one of the big things of developer relations. A lot of people think DevRel is, you're an advocate, you get on a plane, fly to a conference and talk there. So, well, no.
Yeah, sure.
A lot of what we do is actually being the voice of the developer internally. So anything we do to get product feedback is good. And obviously with the open source community, there's a huge group of people who might help with that feedback. So it's kind of, we will give you this thing for free. We will support it. We will help you set it up in your CI/CD pipelines. And obviously we appreciate the feedback in return from it. But it's kind of our way of donating to open source, because we rely on so many open source projects to make our software work, and we can't pay everyone because there's too many people. We don't know who they are.
Hard. It's also hard, right? Like, because then you got to figure out, like, okay, like, how do we tier payment? How do we, like, payment is very challenging, because like you can't just give everybody the same amount of money unless you promise to do that forever. You can't pay people, period, because if the money eventually then goes away, that's a problem too. Like, it's challenging, right?
Yeah. So if we can just make an open source project's life a little bit easier, then that's kind of our way of giving back. And I think it's a really good thing that we're doing. So we're still kind of on that lookout for those first set of open source projects who wanna work with us. So anyone who's listening, if we've got an open source project with an API, you want an SDK, reach out. We'd love to work with you to to get this built out, and we'll kind of give you that enterprise tier, all the features and the support that you need.
Yeah, I mean, so just for reference, like I was curious. So I went to the liblab.com site and like write in big bold letters, right? It's like saving developers time, saving big problems, right? Like you're not just trying to like, okay, like we're an SDK generator. No, like you're a developer experience platform, which I think is absolutely awesome. So, as we start to wrap up, so like what are some of the things that you're doing at liblab? Like, well, obviously in being a developer advocate, I'd imagine that you're creating all sorts of great content, but like what are some of the things, like you've done developer relations in other organizations, like what are some of the things that you've been able to do that surprised you, or things that you are enjoying doing while you're there?
So the biggest surprise for me when I joined is, before this I was at Microsoft. Yeah, so
Sure.
5.5 years at Microsoft, 240,000 whatever it is person company, absolutely enormous. And so you do your thing and that's it. And you want to do anything else, there's paperwork and people and process,
Sure.
the machine is slow. LibLab is a startup. It's tens of thousands of times smaller than Microsoft. And so the biggest thing for me is I have to do everything. I mentioned this to you earlier. I saw this meme of Mufasa and Simba from The Lion King, where they're doing their everything the light touches our kingdoms. Everything the light touches is my job description. And it kind of feels like that. And that's, I think, one of the most exciting things about LibLab for me when I joined is everything is my job description. So when it comes to product feedback, I'm not part of a process where I have to get feedback and submit it to a system and then it disappears and all that. The product feedback is, I get this, I go to the engineers, I talk to the engineers about it. I raise the tickets. Sometimes I fix those tickets myself. I'm closer to it. And that feedback might actually be working with the product team about to set a direction for everything. And so there's kind of so much more influence you have across the company as a whole because it's so much smaller. So yes, I'm doing content creation. That's obviously a part of developer relations, but I own the entire documentation platform. I'm not writing a doc. I'm writing the docs because I'm the only person who's in the team that does documentation. So the company blog, I own that. I'm doing videos for YouTube, but I'm also focusing so much on the developer experience. So as we're still in that pre-release phase, it's not about banging out the content and drive more people to it. It's a lot about being that voice of the developer. I'm advocating for the developer. I'm bringing feedback from the people we've spoken to, or feedback from me with my developer hat on, to make sure the experience of using the product is the best we can. So and as we add new features, it's being that voice. So it's kind of everything you think that a developer advocate may or may not do, or developer relations team may or may not do. All of that falls under me, which is really exciting, but also really flipping scary. Because, if it goes wrong, it's just me. If it goes well, it's me. If it goes wrong, it's just me.
I just came up with this thing, like, with great power comes great responsibility, right? Like, I just came up with that. So like, I mean,
that's a good one. I like that.
Like you're free to use it. Just tell everybody that I came up with it. I mean, that's great. Like, I think, doing the, like, when you're building things and being able to create content and you have the autonomy to do the things that you want to do, whether they're the right choice or the wrong choice, like, that's awesome. So, I mean, that's great. Like, I'm looking forward to seeing more content. Like, before we got started, I took a look at, like, the developers.liblab.com site, and, like, right there you see Jim's face. So, like, Jim can't get away from this one. Like, so,
nope. I'm all over this one. But it is very exciting having that opportunity to do that. But as you say, it's with great power comes great responsibility. So if you make a mistake, it affects everything. So it is scary, but you get to touch on so many things that you wouldn't normally do. Like at Microsoft, if I went to an event, I would turn up, maybe write a demo. Now, we did a conference a couple of months ago. I'm doing everything from designing the booth to ordering swag to planning logistics, running the know before you go sessions, and all those kind of things. So you get to do so many more things, and that's
you're kind
one of the
like
really exciting things about moving for a big company.
Yeah, it's like, so it's kind of like you're like an entrepreneur, right? You're kind of like running your own little business inside of a business, which I think is really, really cool. And it's an excellent way to, like, not just like learn how to run a business, which I think is valuable to a lot of folks, but like, you get like the full scope of the experience, right? Like you're working with folks in
Hmm.
product, you're working with engineering, you're working with customers, you're working with the community, you're doing all these things. And, like you have an opportunity to, not to be cheesy, but like, drive impact in all these different areas, which is awesome. And I'm looking forward to learning more about it. So if like folks that are curious, like I highly recommend like you take a look at liblab.com. If you're not already following Jim, like you can find them at Jim Bob Bennett. That's JimBobBennett on Twitter. And there'll be links to other places you can follow Jim on the video description and the podcast description for this video. And then obviously we'll have some links to like some of the stuff that Jim's doing. So with that, like we've had a great conversation here. Like we've talked about kind of your career progression, kind of ebbs and flowing through some different topics, and I've really enjoyed it. And I'd love to kind of get your thoughts. As we wrap up, if there's, if you can think of the conversation we've had, we've kind of gone through your career, we've kind of gone through some miscellaneous topics. How would you summarize this conversation and all the topics that we were hitting, but you only had a few words to do it?
I think the way to summarize it is look for the things you love and do them.
Yep.
I think that's kind of how I've lived my career is if I look for things that I love, and if I don't love it, I stop doing it and try and find the next thing that I love. So, look for what you love and then do it.
Yeah, like I mean, if you were to use one word, I think the word there is love because you said it like 4 times in one sentence, which is pretty awesome. Like, you
Yeah,
gotta
I
you gotta
mean,
love what you're doing for sure.
yeah,
Yeah.
yeah. I love what I do. I was loving being at Microsoft for a while, and then I wasn't, and so I needed to look
Yep.
for something that I love doing. And the yeah, I hate APIs. I love SDKs, and yeah, with liblab actually before I joined, there's a video from the CEO which is kind of sent to all their or prospective candidates, and he's basically says, the philosophy at liblab is smart but kind. You have to be
Mm,
smart, but you have to be kind. If you're not kind, you're out. And so yeah, I love what I do because I'm surrounded by kind, helpful people
yeah.
who empower me to do the things that I love doing. And yeah, I get to do what I love. I love helping people. I love creating great content that can support people. I love being able to build great developer experiences. So I'm doing what I love, and that's kind of all throughout my career. When I stopped loving something, I moved on to the next thing, trying to find what it is that sparked that love again, and did more of it.
And you can't really hate somebody for just looking for things they're interested in, right? Like so kudos to you. So for folks, I kind of, head up liblab.com, find you on Twitter/X/whatever. Like, do you have any other like parting words before we sign off for today?
Just yeah, we're coming to the end of the year. I hope everyone's had a great year. As we move into the next year, I hope things get better. I know the world is a bit of an unpleasant place in some parts of it.
Sure.
So maybe we all need a bit more love, not just in what we do, but in how we live our lives. Maybe if we all had a bit more love and shared a bit more love, next year could be even better.
I couldn't have said it better myself. So if I don't talk to you again, have a happy holiday. To the folks tuning in live and listening in the future, you have a happy holiday as well. And again, like to echo my friend Jim, like find the things that you love, be kind to one another, and hopefully things just work out. So that's it for me today. This is Isaac Levin from Coffee and Open Source, and I hope you have a great rest of your day. Take care.